Moose. This is the research we presented in WCNC 2022. With this research, we trying to propose scalable blockchain architecture for 5G enabled IoT with supporting sharding and network slicing. These are the authors of this work: Eranga Bandara, Sajin Shetty, Abdul Rahman, Ravi Mukkamala, and Supin Lias. First of all, I will give a bit introduction about me. I am Eranga Bandara, currently working as a senior research scientist at IMAS, Virginia, US. I involved with various research on blockchain, distributed systems, cybersecurity, machine learning, price design, machine learning, with federated learning. One of our major motivation of doing research is we always try to do research and apply this research into real-world applications, basic production-grade applications. Most is one such platforms that we have developed based on our one of our research work. This is me. I'm available on Twitter. This is my Twitter username. If you want, you can contact via Twitter as well. Okay, first let's get some background information which relate to 5G and network slicing. Basically, 5G network slice enables IoT networks to connect billions of different objects, providing high quality of service, high network capacity, and advanced system throughput. Due to the huge amount of data and devices available, the complexity of configuring, managing, and security networks is increases. So that's the nature of the 5G. Due to this reason, there are some major challenges to be addressed in the 5G environment. Main thing is decentralization, transparency, data privacy, and security. In 5G network slice orchestration is a major thing, and data provenance and management. These are the main challenges we need to address in the, especially in the 5G network slice environment. We could adapt blockchain technology to offer the innovative solution to overcome these challenges in 5G environment, especially in the network slice environment. However, integrating existing blockchain systems with 5G enabled IoT would pose challenges to the 5G goals, because 5G mainly deal with high throughput and high speed. When comparing with existing blockchain systems, so most of the existing blockchain system doesn't facilitate the functionalities which required in 5G. For example, they doesn't support high transaction throughput, high scalability, and real-time transaction processing. And in network slice environment, they couldn't operate with sharding-based consensus mechanism, and analytics doesn't support. In network slice environment, especially handling network slice management and orchestration is another challenge. These are the challenges we could face when integrating existing blockchain systems with 5G enabled IoT environment, especially in the network slice environment. To address these challenges, so we have designed the novel blockchain system for the 5G enabled IoT. The proposed blockchain system is Moose. Moose basically support high transaction throughput, scalability, real-time transaction processing. In other main thing is it supports sharding-based consensus and data analytics. To handle the price preserved machine learning, we use federated learning-based approach. Data could be kept independently in price preserved manner in different network sizes. We could build machine learning models based on the data on different network sizes and aggregated them by using federated learning-based approach. With the proposed blockchain system, we can facilitate various functionalities in 5G enabled IoT. Now let's look at the architecture of this system. This is the high-level architecture of these systems, especially in network slice environment. In network slicing, there's a different network slices. Each and every slices deal with different UIs. Maybe one slice could deal with drones, other one maybe connected vehicles, and other one deal with different sensor data. So that's the nature. In each and every network slice, they have their own 5G core environment. So that's the way network slicing works. Our main goal is to deploy an independent blockchain network on each and every slice. We call it blockchain shard. So in that case, so this blockchain shard can work independently without depending on other shards. So it's similar for all the shards. They can come into the local consensus based on the transactions they are processing. Based on the requirements, so based on the connectivity, so they can reach the global consensus. Basically, we can facilitate inter-shard communication by using uh, sharding-based blockchain architecture. They can high-level IDIs, so they can work independently. Basically, work come into the local consensus independently. And based on the requirements, they can reach the global consensus as well. For local consensus, we use Kafka. For global consensus, we use Raft-based model. If you dig into the how the blockchain system looks like in the independent blockchain chart, this is how it's look like. Each chart can have different blockchain nodes. Then these charts interact with the independent 5G core environment. In here, these are the blockchain nodes, so they can reach into the consensus by using Kafka. So this sharding-based blockchain we support it with Docker Kubernetes-based environment. So there are different functionalities implemented on each and every shards. We have implemented federated learning functionalities and storage functionalities and uh, consensus reaching functionalities and smart contracts on this blockchain environment. That's the architecture of the local blockchain shard. Now, let's look at the main functionalities of the system. There are four major functionalities. We propose to deploy sharding-based blockchain network on 5G network slice environment. Other thing is we propose dynamic network slice orchestration and management using blockchain smart contracts. Third thing, we propose a mechanism to deploy 5G core services on edge network where users can quickly reach. Finally, we propose a method to incorporate federated learning-based privacy-preserving machine learning model in the network slice environment. If you look at the first thing, sharding-based blockchain network. In sharding, we use sharding-based consensus architecture, where independent blockchain network can be deployed on network slices based on the requirements or the agreement. So each network slice can reach into the global consensus. The inter-shard or inter-slice communication can be done via the blockchain. That's the main idea. In here, this is how it's inter-shard blockchain network works. So there's a different blockchain charts operates. Each chart have different blockchain nodes. In here, when reaching local consensus, each chart selects a node from within the chart. We call it local lead. Then local lead generate the local blocks based on the transactions they're processing. Then these local blocks broadcast to the Kafka. So then when reaching the global consensus, one shard will be selected to the create the global block. So basically, one chart's ELK node. We have a specialized node called ELK, which handle the consensus. One chart will be selected to the create the global blocks. So then assume chart 2 CLK not selected to the create global block. Then what it does is it takes the local blocks published by the other charts and order the transaction based on the timestamp order and create the global block. Then broadcast the created the global blocks to the other charts. Then other charts ELK nodes, basically local leader, will be validate the transactions and vote for that block. Basically design that block. Then once majority of shards validate the local block, so that block will be considered as approved block. Then approved block finally will be broadcast to other shards. So then they append that block to their own ledger and process the transactions. That's how sharding-based consensus works in the proposed system. Second thing is network slice orchestration. We propose dynamic network slice orchestration and management with blockchain smart contract. We incorporate network slice orchestration library to handle the dynamic network slice orchestration functionalities. Our main idea is to store the network slice templates in the blockchain ledger. Then, based on the customer's requirement, network slice can be launched with the specification on the network slice templates. In here, our final ultimate goal is build the network slice marketplace by using blockchain and smart contracts. This is how it looks like. We incorporate network slice orchestration manager called Katana. We delegate the orchestration functionalities to that Katana network slice manager. It has APIs to create, update, or delete basically to manage network slices. What we do is our blockchain smart contract interact with the Katana network slice manager to manage the orchestrate the network slices. That's how we deal with the dynamic network slice orchestration. Third thing is we propose 5G core edge network. In here, currently, most of the existing 5G core network deployed on the centralized cloud environment. All the services are deployed on the cloud environment. In here, instead of deploying all the services on centralized cloud, we're trying to deploy 5G core services on the edge network. The main idea is to frequently access 5G core services, maybe AMF, SMS. We're trying to move to the edge network. In here, our main method is we trying to deploy 5G core network with the kubernetes-based orchestration system. In here, we deploy a Kubernetes cluster in the edge nodes, edge network. These edge nodes could be a local cloud instance or cloud instances or any server which quickly accessible by the RANs or UV devices. Then by using Kubernetes, we're trying to distribute the different services on the 5G core environment into different edge nodes. For example, ANF and SMF. So we can deploy it on the edge node, which RANs can quickly reach. So that's the main idea. We distribute the functionalities of the 5G core services onto the edge nodes. Then final thing is federated learning. So we're trying to incorporate privacy preserving federated learning mechanism in the network slice environment. Uh, we use this machine learning model to detect the network attacks, anomaly detection, channel customer billings, dynamics orchestration of network slices, and various machine learning functionalities can be implemented with this machine learning model. The main idea here is to different network slices can have their own data. Then we can build a machine learning model in each network slices in price preserving manner. Then the build local machine learning models can be averaged into global models by using federated learning. In here, that idea is each network slice build a local model. Then different network slices have their own local models. Finally, we average these own local models into the global model by using federated learning. We build some federated learning mechanism by using blockchain enabled environment. Uh, Finally, the generated models can be integrated into blockchain smart contract to do predictions based on the real-time data. It could add contrast to the 5G applications while preventing attacks such as misrepresented or spoof machine learning model iterations. That's the thing. This is how the machine learning model works. We can build machine learning models, and we could use these models in the blockchain smart contracts. Uh, at the end, so with proposed system, we incorporate blockchain, machine learning, and AI to solve the challenges in the 5G enabled IoT. Basically, in next generation, will be 60. 60 is identified as the 5G plus AI. So basically, with this research, we already addressing the 60 requirements since we incorporate 5G with the privacy preserving AI. In future release, future research work, we trying to publish new papers about this addressing 60 requirements with the most blockchain environment as well. Okay, that's it from my side. If you have any questions, we can discuss them now.